So what about the possibility that the universe is so large that we can't tell if two parallel lines intersect eventually, in terms of figuring out the shape of the universe? Well, a couple things. Number one, we can make triangles. I mentioned this in the other video, but in flat space, if you make a triangle, the angles of the triangle will always add up to 180 degrees. And in curved space, if you make a triangle, the angles will always add up to more than 180 degrees. And this is regardless of size. Doesn't matter if we measure a triangle on the scale of the universe or a triangle on a piece of paper right here. And when we make triangles in our space, they appear to add up to 180 degrees. Hence, the universe is likely flat. But that's the first thing. The second thing is I think you misunderstand a core tenet of science. Science leaves open everything to be disproven. We always accept that we only know as much as we know right now. That doesn't mean, however, that you can't make any claims. We can say, based on the laws of the universe that we observe, space is most likely not spherical. And then we present that evidence. Now, that hypothesis is presented with the built-in caveat that more information can always disprove it later. But that doesn't mean we don't know. In science, we know things based on the evidence we have right now. And that goes for everything from gravity to quantum mechanics to biology to chemistry. There is always a chance that somewhere on some scale, somewhere out there in the universe, we will get conflicting data that will make us have to rethink all of our knowledge in those fields. But we don't respond to that possibility with, we simply don't know. We respond to that possibility with, this is what we know right now. So just because there's a possibility that on a big enough scale in places we can't observe, space might end up being spherical, that's not a reason to not make observations about space right now. There's also a chance that at a large enough scale in space we can't observe, space can be any number of shapes. Just because there's always a possibility that science can be revised and rewritten doesn't mean we don't know. What it means is we know what we know, and what we know is that the evidence we see so far points toward a flat and non-spherical universe. Does it mean the universe is definitely a torus? That's something we don't know yet. But a torus is one model that fits the observations we have. There's also the saddle model. There are other hypotheses as well. And the reason not one of them is taken as exactly what we know is because they all fit our observations well. But a spherical universe does not. And an infinite universe, for the most part, does not. And as we say in science, extraordinary claims require extraordinary evidence. So if you believe the lines might meet, the first thing you have to do is present evidence.